First MCQ is hydrocarbons are classified into aliphatic and aromatic on the basis of. Now look at the option A, chemical composition. This one is the wrong, okay, because like what is chemical composition? Carbon and hydrogen, they both are made up of carbon and hydrogen chemically, so we can say that they are same in chemical composition, okay. Now the option B is physical properties, okay. So what is physical properties? Physical property may be the state like liquid, solid and gas, or boiling point, melting point, okay. So the physical property may be the same in both. Like if we take the example of benzene, benzene is liquid in state, okay, benzene is liquid state. And in aliphatic compound, if we take the example of hexane, pentane, or we can say hexane, so in aliphatic they are hexane, pentene or heptene, they are liquid in nature, okay. So we can say that the physical property of aromatic and aliphatic compound may be the same, okay. So hydrocarbons are classified into aliphatic and aromatic on the basis of chemical properties, okay. They both have different chemical properties. Like in case of aromatic, we know that aromatic compound react differently from aliphatic compound, like they have different behavior in case of chemical reaction. That's why we can say that they are classified on the basis of chemical properties. Option C is correct here. Second, which of the following is alicyclic hydrocarbon? Now what is alicyclic? Alicyclic are compounds which contain a cycle but they are not aromatic, okay. Look at the option A, cyclohexane. Option A is correct here, okay, because cyclohexane contain a cycle but it is not an aromatic compound, okay. Look at the benzene. Benzene has a cycle but it is aromatic in nature. Isobutylene don't have any ring, okay, so this one is incorrect. And new pentane also contain no ring. That's why option A is correct here. The third one, which one is not a hydrocarbon? Fourth, hydrocarbons which contain double bond between CC atom are called. Option A is paraffins. Paraffins are alkane and they contain single bond. Look at the option B, arenes. Arenes are, we can say, aromatic compound, okay. Arenes are the aromatic compound, okay, and they contain delocalized pi bond, or we can say pi electrons, so we cannot localize their double bond between carbon-carbon atom, okay. Look at the C, acetylene. Acetylene are called ethyne, which means that they contain 3 bonds between carbon atoms. And look at the option D, olefins. Olefins are called alkenes, okay, and they contain localized double bond between carbon-carbon atom. So option D is correct here. Grignard reagent is the name given to the organic compound in the common system. This name is given according to the dash of the compound, property, history, source, and option D is discovered. So option D is correct here, okay. Its name is given according to the scientist name, so the name is Grignard reagent. Here option D is correct. N-pentane means straight chain. Isopentane and new pentane can be differentiated by. Option A is molecular formula. This one is incorrect, okay. The molecular formula for pentane, isopentane and new pentane is same, okay. They all have same molecular formula like C5 and H12. Option B is color. So these three have same color, okay. So option B is incorrect. C is boiling point. Now option C is correct here, okay. These 3 compounds can be differentiated on the basis of boiling point. Like we can say that boiling point is inversely proportional to the branching, okay. So greater the branch, lower will be the boiling point. So the boiling point of new pentane is smaller. The boiling point of isopentane is higher as compared to this one, and the boiling point of N-pentane is higher as compared to isopentane, okay. So option C is correct here, and we can say that this one is greater and also this one is greater, okay. Look at the 7. The decrease in angle in cyclopropane is due to the. Option A is minimum overlap of sp2 hybrid orbital. This one is incorrect, okay, because cyclopropane alkane has sp3 hybridization, okay, so this one is incorrect, okay. Maximum overlap of sp3 hybrid orbital. This one is also incorrect, okay. The maximum overlap only occur in straight hydrocarbon, straight alkane, okay. In cyclic form, what happened? The minimum overlap of sp3 hybridized occur. The maximum overlap occur in the straight, like if this one N propane, then it would be maximum overlap of sp3 hybrid orbital. Now it is cyclopropane, okay. For cyclopropane, option C is correct. Minimum overlap of sp3 hybrid orbital. Look at here. In case of straight, the angle is 109.5, okay. And in case of cyclopropane, the angle is 60 degree. So the decrease has occurred because of the minimum overlap. 8. Which one is more reactive? Now look at here. We know that here cyclopropane is more reactive because cyclopropane has greater angle strain, okay. So we can write this like angle strain is directly proportional to the reactivity, okay. Angle strain is directly proportional to reactivity. So we know that greater angle strain is present in cyclopropane, so it will have greater reactivity, okay. Propane is the one which is more stable, okay. Propane and butane are more stable, and after these two, cyclobutane is stable, okay, and the cyclopropane is unstable, okay. So this one is more reactive, and this angle strain is caused by minimum overlap of sp3 hybrid orbital. Greater angle strain is present in cyclobutane, cyclopentane, cyclopropane. So option C is correct, okay. Cyclopropane has greater angle strain. Like we can say that from 109.5, this one is for straight, okay, straight chain. In cyclopropane it is 60 degree, okay, and in cyclobutane 90 degree, and in cyclopentane the angle is greater than 90 degree, okay. So we can say that the greater angle strain is present in cyclopropane. Angle strain is the decrease in the angle, okay. Homolytic bond fission result in the formation of free radicals, okay. Like let's suppose this is H2, okay, or we can say H into H, okay. Now what is homolytic fission? The bond breaking, like one electron is gained by this one and one electron is gained by this one, so it will be like free radical, okay. This one is homolytic fission in the molecule. The electrophile and the nucleophile is given in case of heterolytic bond fission. 11. In a bond fission, positive and negative charge species are produced. This type of bond fission is called heterolytic bond fission, okay. Option C is correct. The common reaction of alkanes are, now we know that alkanes are the most stable compound, that's why it will undergo substitution reaction, and in substitution reaction alkanes will undergo free radical substitution, okay, because alkanes are more stable and free radicals are very much highly reactive, okay. So that's why only free radical will do the reaction with alkanes, like the reaction will be substitution. In chlorination of methane, if chlorine is used in large concentration, then the major product form is. Now we know that when chlorine is used in large concentration, in that case the CCl4 will form, okay, tetrachloromethane. And when the when methane is in greater concentration, then in that case what will happen? CH3Cl will be in major product, okay. When methane is greater concentration, then in that case the major product will be CH3Cl. In a very limited amount of oxygen, the combustion of methane produces carbon soot plus water, okay. This one is the reaction present in your book. Which of the following is more stable alkene? So the most stable is option D, 1,3-butadiene. Now look at this structure. This one is 1,3-butadiene. Now we know that when the alternate double and single bond is present, then in that case what happens? The delocalization of pi electron occur, okay, like conjugation happen in this. When conjugation occur, so in that case it will be the most stable alkene, okay. Option D is correct here. Or we can say that this one is the conjugated alkene, which is the stable one. Dehydration of alcohol by H2SO4 produces alkene. This reaction. Now look at the MCQ, dehydration of alcohol. Now this D means removal, okay, and we can also say elimination. So in this case the reaction is elimination reaction. Dehydration means D mean removal, and we can also say elimination. When propene is reacted with HI, acid halide, then dash is obtained. Now look at here, this one is propene, okay, 3 carbon compound. Now we know that when this one bond breaks, what happen? One carbon will get positive charge and other will get negative charge. Now according to Markovnikov rules, that carbon which contain greater number of hydrogen, this carbon will get negative charge, okay, and hydrogen will add to that carbon. Like look at here, we know that this one carbon contain 2 hydrogen bond and this one contain 1 hydrogen bond, okay. Now this one will get negative charge when this, like, and this one will get positive charge, okay. And when iodine breaks, what will happen? This I will get negative charge and hydrogen will get positive charge. So in this case 1 2 3 carbon, 1 hydrogen, and here iodine will be attached, okay. And now look at here, which one compound is formed? 2-iodopropene has formed, okay. So option B is correct here. Vicinal dihaloalkane. Vicinal dihaloalkane are produced when an alkene is reacted with. Now we know that when we do halogenation in alkene, so in that case vicinal dihaloalkane will be produced. Look at the option C is correct, okay. Halogen molecule, this halogen, like let's suppose Br2, okay, this will break down, Br positive and Br negative will form and it will be combined to alkene, okay. Like look, this one is, let's suppose, carbon carbon. When this bond is broken down, one bromine will be attached to this one carbon and other bromine will be attached to this one carbon, okay. So when we react halogen molecule with alkene, we will get vicinal dihaloalkane. Vicinal means on adjacent carbon atom, okay, the atoms of halogen on adjacent carbon atoms. So this one is vicinal. Brown color of bromine disappear when it is added to cyclohexene. Like look at the other options, this one is alkane, this one is also alkane, and this one is also alkane. So no addition will occur, okay, in these 3 compounds. Look at the C, this one is alkene, okay. When bromine react with alkene, this bromine will be added, addition reaction will occur in cyclohexene, and what will happen? Bromine will lose its color, okay. Halohydrins are produced when alkenes are reacted. Now what is halo? Halo mean halogen, okay, and hydrins means OH, okay, OH group. So now look at here, when we react alkene with HOX, okay, so we will get halohydrin. Option D is correct here, okay. Like this one is ethene, okay. Now when we react with HOCl, what will happen? HO will come here and Cl will combine to this one, so we will get COH and Cl. So this one is halohydrin, okay. Option D is correct. 21. An alkane produced propanol and methanol upon ozonolysis plus ZnH2O. The starting alkene was. Now look at here, propanol and methanol, which means that they must contain the 4 number of carbon, okay. It must be bute. And look at here, option B, butane, which means ozonolysis do not occur in alkane, okay. So option B is incorrect here, okay. Now look at here, the trick is here that just draw, like I take this option A, butene, okay, 2-butene, this. Now break this double bond here, okay, like look at here, okay, and here is the 3 hydrogen, okay. Break this double bond and combine oxygen with this, okay, like CH and this one will give CH3, okay, and with this double bond write O, okay. And look at this one, take this and combine double bond with like CH and CH3, okay, and double bond, okay. So this one is the trick for the ozonolysis, okay. Break the double bond and combine oxygen with it. Now look at the product is ethanol, and here it is also ethanol, okay. So option A is incorrect. Here the C option is correct, okay, 1-butene. When you put the double bond here, you will get methanol and propanol, okay. Like you should practice it on your when you practice it, you will get to know that 1-butene give propanol and methanol. Which alkenes show conjugation, okay. Now for conjugation, the alternate double and single bond should be the condition, okay. Now look at here is the double bond single and single, here is the single double and single. Look at the D option, double single double, okay. So this one is the condition for conjugation, so option D is correct here. 23. Conjugation affects the option A, hybridization of carbon atom. Now this one is incorrect, okay. Like if we take this one compound, okay, so these all carbon is sp2 hybridized, okay, and conjugation do not affect the hybridization of carbon, okay. Look at the B option, bond angle. Now bond angle do not affected by conjugation, only the bond length is affected by conjugation, because these pi electron are delocalized, okay, and due to delocalization we cannot differentiate between the double and the single bond, okay. So the bond length is same for this one, okay. Sorry, the bond length is not the same, okay. Like the double bond here is a little longer than the normal double bond, okay, and here the single bond is shorter as compared to the normal single bond, okay. So it means that conjugation affects the bond angle bond length only, okay. Glucose and fructose are isomers. What kind of structural isomerism exists between them? Now look at here, glucose contain aldehyde functional group and fructose contain ketone functional group, okay. So it means that they are functional group isomerism. They contain functional group isomerism and they are the functional group isomers. Option A, geometric isomerism, this one is incorrect. Metabolism, this one is incorrect. Look at the C, functional group isomerism, so option C is correct. Functional group isomerism is the one which contain different functional group, okay. Isomerism in which the order of atom bonding is same but the arrangement of atom in space is different are. So here option D is correct, okay. Geometric isomerism, when the arrangement of atom is different in the space, then that isomerism are functional group isomerism. Which one is the trans-2-butene? Now look at here, option A. This one structure, look at here. This carbon contains two same groups, so that's why this one is not trans-2-butene. Look at the 3 carbon double bond carbon, and this one carbon contain different groups, this one also contain different groups, so and they are on different side, so this 3 number show trans-2-butene. But this one is cis-2-butene, okay, and this one is not trans or cis, okay. So option C is correct. 27. Methanol and methanol. Methanol contain aldehyde functional group and methanol contain alcoholic functional group. So these two are the functional group isomers. Option A is correct here. 28. The maximum number of isomers for an alkene with molecular formula C4H8. Now in case of alkene, first of all you have to see how much double bonds are there, or we can also say degree of unsaturation, okay. So for double bond there is a formula, degree of unsaturation, okay, degree of unsaturation. So look at here, C4 and H8. Here the formula is C carbon minus H divided by 2 plus N divided by 2 plus 1, okay. Now look at here, carbon is 4, okay, 4, and hydrogen is 8 divided by 4 is equal to minus 4, and nitrogen is not present, so don't mention this one term, and plus 1, okay. 4 minus 4 is equal to 0 and it will give 1. So it means that this compound contain only one double bond. Okay, now look at here. These are the 4 isomers possible for the C4H8. Okay, so the first one is here. You should put the double bond in first carbon with first carbon. Okay, and this one is, look, isobutene. Okay, and this one is cis form. Okay, cis 2 butene, and this one is trans 2 butene. Okay, so these are the 4 possible structure for the C4 and H8. So option C is correct here. Okay, 29. Metabolism is a type of, option A, structural isomerism. Okay, which one of the following compounds does not show the position isomerism? Look at here, the MCQ was which one do not show the position isomerism. Look at here, dichlorobenzene. This one shows the position isomerism. Like if we change the position of chlorine to here, it will be meta. Okay, in meta position. When we bring this chlorine here, it will be on para position. Okay, now it is ortho. Okay, so it means that this one shows the position isomerism. Look at this one. This is propanol. Okay, 1 propanol. When we bring this hydroxyl group here, it will give 2 propanol. So it means that it also shows the position isomerism. Look at the third one, butane. Okay, when this one is now 1 butane. When we bring this double bond here, it will give 2 butane. Okay, so it means that position isomerism is also shown by this compound. Look at here, this one is now 1 propene. Okay, 1 propene. Now when we bring this double bond here, still it will be 1 propene. Okay, because we start the numbering from there where the double bond is present. Okay, so when we bring this double bond here, we will start 1 2 3. Okay, so it will be 1 propene, and in this case 1 2 3, it is also 1 propene. So it means that propene do not show the position isomerism. So here option D is correct. Okay, 31. The compound having molecular formula C4H10O can show. Now here some options are given: functional group isomerism, metamerism, and positional isomerism. So first of all, we have to find whether this compound contains double bond or not. Now look at here. We know that the formula for finding the bonds, double or triple bond, is du, degree of unsaturation. Okay, so C minus H divided by 2 plus N divided by 2 plus 1. Okay, so the number of carbon is 4. Okay, and 10 divided by 2 will give 5, and plus 1. We know that nitrogen is not present, so just ignore this one. Okay, so this one will give 0. It means that there is no double bond. So the conclusion is that this compound is either ether, because ether contain oxygen and having single bonds. Okay, or this compound is alcohol. Okay, so there is these two possibility that this one is either ether or alcohol. Now look at here, the structure may be like this. Okay, here is OH. Okay, and if you want to find the functional group isomerism, so it will be this one is alcohol and this one is ether. Okay, these two are the functional isomerism. So yes, this one shows the functional isomerism. Now let's find the other one, which is metamerism. Now let's take this one. Okay, we know that metamerism is the isomerism which has different chain of carbon atoms around the functional group. Okay, so look at here, the carbon atoms are 1 2 and 1 2, and we can also write it like 1 is here, 1 carbon, and 3 carbons are here. So it means that this compound like C4 and H10 can shows the metamerism also. Now let's find the positional isomerism. Look at here, let's take this alcohol. Okay, here alcohol is on carbon number 1 and here it is on carbon number 2, so this compound C4 and H10 can shows the position isomerism also. Look at here, option A was metamerism, functional group isomerism, and position isomerism, so option D is correct here. Okay, look at 31. Methoxymethane and ethanol are. Now look at here, we know that methoxymethane is the ether. Okay, and ethanol are alcohol, so it means that they have different functional groups, so they will be functional group isomerism. Okay, like methoxymethane is CH3O and CH3, and ethanol is CH3, CH2, and OH. Okay, this is ethanol, so they show the functional isomerism. Now let's see the 33. Isomerism which is only found in alkene. Now we have to find such isomerism which is only found in alkene, not in alkyne, not in ether, not in aldehyde, only in alkene. So we know that cis-trans isomerism is only found in alkene, because for cis-trans isomerism there is one condition, that they must contain, like carbon-carbon atom must contain the double bond. Okay, so this double bond is the condition for cis-trans isomerism. So cis-trans isomerism is only found in alkene. the following two are, now look at here, this is butene and this is cyclobutane. Okay, so these two are ring chain isomer. Okay, so we can say that they are chain isomers and they are functional group isomers also, because we treat the double bond and the ring as functional group. Okay, so they are chain isomers and functional group isomers, so here option C is correct. 35. In alkane form isomers if the number of carbon atom is at least, so the number of carbon is at least 4. Okay, 4 carbon atom forms the isomers. Okay, look, they are talking about the alkane. Okay, straight chain alkane. Like if we take, let's suppose take the propene. Okay, propane, C, C and C. Now here is only one structure for propane. Okay, so it means that propane do not shows the isomerism, only butane and higher alkanes shows the isomerism. Okay, which of the following compound doesn't show the cis trans isomerism? Now look at here, this 2-butene means that this one shows cis trans isomers. Let me show you the structure. Look at here, this one is 2-butene. Okay, this one shows the cis trans isomers because the conditions are like double bond is present and one carbon, each carbon contain different groups. Okay, so this one shows the cis trans isomers. This one is 1-butene. Okay, 1-butene do not shows the cis trans isomers because this one carbon contain the same group like hydrogen. Okay, and this one also contain the same group, so this one do not shows the cis trans isomer. Now let me show you 1,2-dichloroethylene. Okay, now look at here, one carbon number 1 and this is carbon number 2, so 1,2-dichloroethylene. Like if we take the ethane and we remove one carbon or one hydrogen, so it will be ethyl. Okay, if we remove the 2 hydrogen, then it will give ethylene. Okay, so this one is 1,2-dichloroethylene and this one shows the cis trans isomers because each carbon has different group attached. Okay, so look at here, which compound does not show, so option B is correct here. Which carbon in the following compound is chiral carbon? Now what is chiral carbon? The carbon which has 4 different groups. Okay, if we look at this one, okay, this one contains 3 same groups, so this one is not chiral. This one carbon contain the 2 same group, so this one is also not the chiral. Look at this carbon contain the ethyl group, okay, the hydroxyl group, the methyl group and hydrogen, so it means that this one carbon is the chiral carbon. Now look at the option B, second carbon. So we start the numbering from there where the functional group get the lower number. Okay, so we have to start the numbering from here 1, 2, 3 and 4. Okay, so the second carbon is chiral carbon. 38. Dextro and levorotatory isomers are known as, so we know that dextro and levorotatory isomers are the mirror images of each other. Okay, so we can say that they are enantiomers. Okay, non-superimposable images of each other, so option C is correct here. Look at the 39. Which one is the correct mirror image of 2-amino propanoic acid? Now look, this one is so easy. Option B is the proper mirror image, like CH3, CH3, NH2, HH and C double bond OH, C double bond OH. Okay, so this one is the mirror image. Okay, correct mirror image, and the rest of the options are not the correct mirror images. Isomers which are not superimposable are called enantiomers. Okay, option D is correct here. Look at 41. Which one is least stable alkyne? So option A is 1-butane, option B is 2-butane, and option 3 is 1,3-butadiene. Now look at here, they are their structure. So this one contain one triple bond, okay, and this one is a terminal carbon, so it means that an electrophile can easily attack on this one. Okay, so it means that this one is least stable, okay, and more reactive. Look at the 2-butane. Triple bond is present between the 2 carbons. Okay, like look at here, 2 carbon is here and 2 is here, so they are some like symmetric. Okay, and the symmetric one is the stable one. Okay, and also the electrophile cannot attack here easily. Okay, and look at here, this one is pi, sigma and pi bond. This one carbon shows the conjugation. Okay, so this one structure, so it means that this one is also stable, so option A is the least stable. 42. Alkynes are mostly prepared by elimination reaction. Like if we take the alkane and we remove the 4 carbons, sorry, not the carbon, we remove the hydrogen from them and they make the alkyne. Okay, so they are mostly prepared by the elimination reaction, because in elimination reaction the sigma bonds are broken down and the pi bonds are formed. Okay, so they are mostly prepared by elimination reaction. Landslide Catalyst is used to stop the hydrogenation of alkyne at alkene formation. The catalyst is composed of, in Landslide Catalyst, what happened? The palladium catalyst is taken and it is poisoned by BaSO4 and quinoline. Okay, beryllium sulfide and quinoline. So option C is correct here. Okay, ethine plus HBr gives the final product. Look at here, this one is ethine. Okay, and when we react HBr with it, so this one bond will be broken down and it will be negative and positive. So hydrogen will be attacked on this negative and HBr will attack on this positive. So it will be something like this. Okay, 1-bromoethene. And after this, what will happen? This bond will be broken down. Okay, and let's suppose this carbon has negative and positive. Okay, so this one will be CC3 hydrogen. Okay, and 2 Br and 1 will be hydrogen. So we have to start the numbering from here. Okay, 1 and 2, so it will give 1,1-dibromoethane. Option C is correct here. Okay, like in case of ethine, when we react ethine with hydrogen bromide, the reaction will be continue up to the ethane. Okay, up to alkane level. Okay, so this one will give 1,1-dibromoethane. Okay, acetaldehyde is obtained when dash is hydrated in the presence of H2SO4 or HgSO4. So we know that when we react acetylene with the water, so it will give acetaldehyde. In case of ethene, what happened? In case of ethene, the alcohol forms. Okay, alcohol forms, while in case of acetylene, the arrangement occurs and it gives the acetaldehyde. Okay, ease of hydrogenation of hydrocarbon is the following order. So the order is ethene, ethine and ethane. Option C is correct. Okay, we can easily hydrogenate this ethene, then ethine and then ethane. Okay, because in case of ethene, what happened? The electrophile can easily attack on ethene. Okay, while in case of ethine, the volume is greater and the charge density is less on pi bonds. Okay, that's why the electrophile do not attack easily from this, and you know that ethane is saturated and it do not give the hydrogenation. Only substitution reaction occur in ethane. Okay, so here option C is correct. Ethyl acetylene and dimethyl acetylene were passed through a container having inlet and outlet containing ammonical silver nitrate solution, which gas is trapped in the container. Now look at here, these are the formula for dimethyl acetylene. Look, dimethyl, and this one is ethyl acetylene. Now we know that what happened, the ammonical silver nitrate will be react only for terminal alkyne. Okay, when terminal alkyne react with ammonical silver nitrate, then what will happen? It will give acetylide. Okay, so in this case only this one will be trapped in the container and this dimethyl acetylene will be passed out. Okay, so option B is correct here. When acetyl chloride is reacted with benzene in the presence of AlCl3, okay, the reaction is called Feudal Carboxylation. The product obtained is methyl phenyl ketone. Okay, this one is the product, like look, C double bond O and CH3, or we can also say acetophenone. Okay, like this. So this one is methyl phenyl ketone obtained. Which one is a phenonium ion? Now look at here, option A is the phenonium ion. Okay, when the electrophile attack on benzene ring, what happened? This bond is broken down. Okay, and this one get negative charge and this one get positive charge. So on negative corner, what happened? The electrophile attack on this one. Electrophile is the positive charge species. Okay, so it attack on this one and in turn they make the phenonium ion. Okay, or we can say the carbonium ion. Option A is correct here. Okay, which one is the major product expected from the following reaction? Now look at here, this one is the terminal alkyne. Okay, terminal alkyne, or we can say propine. Okay, so when we react this HCl, okay, what will happen? According to Markovnikov Rule, so this hydrogen will come to this side. Okay, because here the number of hydrogen is greater, and this chlorine will come to that carbon where the hydrogen is less. Okay, so it will make CH3, Cl and CH2. Okay, now when we react the HCl again, what will happen? it will give 2,2-dichloropropane. Okay, look at here, when this one bond is broken down, the chlorine will add to that carbon where the hydrogen atom is less, means this one carbon, and the hydrogen will combine to that carbon where hydrogen number is greater. Okay, so hydrogen will come to this carbon and it will make CH3, Cl2, and it will make CH3. So this one will be the major product expected from this one reaction. Okay, so look at here, this one is the correct option. Okay, option D. Look, CH3 plus CH3, and here on the chart side the question mark is present. Okay, it will give ethane. Okay, so in substitution reaction of alkane, what this step is called? Okay, so we have to find that whether it is initiation, termination, or propagation. Now look at here, initiation. We know that at initiation stage the two chlorine ion broken down into free radical, I mean one chlorine molecule. Okay, one chlorine molecule is broken into two free radicals, so it means that this one is not an initiation. And on termination step, first let's see what is propagation. On propagation step, what is there? There is one chlorine. Okay, chlorine is either free radical and CH4 is present. Okay, or either CH3 is free radical and chlorine molecule is present. So this is the, so in propagation, either chlorine free radical or CH3 free radical, one of the reactant will be free radical and other will be molecule. So this reaction is not propagation. Actually this one is the termination reaction. Okay, in termination what happen? The two free radical will combine to give a molecule. Either it is two free radical of methyl, either it is two free radical of chlorine. Okay, or either it is one free radical of chlorine and one free radical of methane. So this one is the termination reaction. Okay, and here the dot is present. In question mark the dot is present, so it shows the free radical. And here the dot is present. Double bond in ethene makes it to attacked by the electrophile. Okay, in double bond, look, this is the double bond. Okay, here the pi bond is present, which is the weak bond, and which means that electron is present for the electrophile to attack it. Okay, so option A is correct here. Look at here, the nucleophile. We know that nucleophile only depend upon only attack on the positive species. Okay, but here the electron are present in X's, that's why electrophile will be the suitable agent to attack on it. Okay, 53. The reaction of 2-butene with HBr gives only one product because, so here option A is correct. Okay, 2-butene molecule is symmetrical around the carbon-carbon bond. Like one product means that it only react according to the Markovnikov rule. Okay, or if it do not react according to the Markovnikov rule, then the product will be same. Okay, so if the 2-butene were not symmetrical, okay, like the unsymmetrical butene is present, then in that case two product will be present. The one is the according to Markovnikov rule and the other would be against the Markovnikov rule. Okay, so this 2-butene is symmetric. Okay, for symmetric molecule what happen? Only one product form, and either it is following the Markovnikov rule or either it is against the Markovnikov rule. The product will be only one and it will be same. Okay, so option A is correct here. Alkenes usually undergo dash reaction. Here is the A option, addition reaction, because in alkane double bond is present, the pi bond is broken down and the reagent combined with these carbon to form the alkane. Okay, so in alkene addition reaction occur. Look at 55. Ethyl alcohol on dash give ethene. Look at here, this one is the ethyl alcohol. Okay, now when on dehydrogenation, what will happen? One hydrogen will be removed from here and other will be removed from here, so still it would be alcohol. Okay, it means that this one is incorrect. Okay, hydration, so this one is, look, single bonds are present, so hydration will not occur. Option C is dehydration. Yes, this one is the correct. Okay, when we remove the hydroxyl group from this carbon and the other hydrogen group from this one carbon, okay, so it will give water. It means that dehydration, water is removed and in turn it is giving the ethene. Okay, it is giving ethene, so option C is correct here. Which one decolorizes the bromine water? Look at here, option C is correct. Okay, cyclohexene also decolorizes the bromine water because the double bond is broken down and bromine is attached to the hexene or either ethyne. Okay, when bromine get attached to them, what happen? The bromine loses its characteristic, okay, its characteristic color, so it means that bromine decolorizes when they are reacted with cyclohexene and ethyne. And look at here, benzene do not decolorize the bromine water. Okay, alkane containing dash carbon atom are waxy solid. Okay, now look at here, up to 4 they are gaseous. Okay, colorless gases. And up to 5 to 17, what happened? They are the liquid. Okay, they are colorless liquid. And higher alkane are waxy solid. Okay, so 18, option C is correct here. Which of the following carbon is double bonded with itself? Now with itself means that the carbon double bond is present. Now look at here, ethane single bond is present. Propane, carbon is double bonded with oxygen, not with carbon. In methanol, the carbon is bonded with oxygen. Okay, in butene, carbon is bonded with another carbon. Okay, so option D is correct. Itself here means that there is two double bond between two carbon atom. Okay, now look at this one. 1 mole of an alkene is given symmetrical. Okay, here is symmetrical alkene, and when ozonolysis occurred, it gives 2 mole of an aldehyde. Okay, 2 moles of an aldehyde having molecular formula molecular mass 44. So it means that the aldehyde have molecular formula 44 mu. Okay, so first of all, what you have to do is just see which aldehyde has the molecular mass 44. Now for formaldehyde, the molecular mass is 30. Okay, and for acetaldehyde, the molecular mass is 44 mu, like CH3, C double bond O and H. This one has 44 mu molecular mass. Okay, now this statement becomes simple. Okay, so simply they have stated that which one of these will give 2 moles of acetaldehyde. Okay, now you have to find that which one gives 2 moles of acetaldehyde. Ethene, look at ethene. Take this ethene and this one is ethene. Okay, now break this double bond and put oxygen for both. Okay, react oxygen are with both carbon. Okay, so it will give 2 moles of formaldehyde. Okay, not acetaldehyde. Now look at here, propene will give formaldehyde plus propene will give methanol and ethanol. Okay, and look at here, 1 butene will give formaldehyde, means methanol, and 1 butene, another compound, it will give the propanol. Okay, so it means that this one is incorrect. Look at the 2 butene. This 2 butene gives 2 mole of an aldehyde, that is acetaldehyde, or we can say ethanol. Look at here, this one is 2 butene. Okay, when you break this one bond, okay, so what will happen? You have to draw oxygen with the one carbon and you have to draw the other oxygen with the another carbon. Okay, so this is the ozonolysis for 2 butene, and this one give 1 mole of acetaldehyde and another mole of acetaldehyde. So it means that 2 moles of acetaldehyde is given by 2 butene. So look at here, option D is correct here. Okay, ozonolysis reaction with an alkene produces 1 mole of formaldehyde or methanol and 1 mole of this propanol. Okay, what is the name of an alkene? Now look at here, carbon 1, 2 and 3. Okay, this one is ethanol. Okay, ethanol 1, 2 and 3. So 3 carbons are present. It means that what will be the compound? It will be propylene. Okay, option A. Look at here, C double bond C, CH3 and H. Okay, this one is H, and when you break this one bond, so the one will be formaldehyde and the other will be ethanol. Okay, so option A is correct here. Bromoethane can be converted into ethene by, look, this one is bromoethane. Okay, we have to convert this into ethene, so just remove this Br and hydrogen, so it will give ethene. Now what will happen? Reaction with alcoholic KOH will convert this into ethene. Okay, so here option B is correct, or you can also says that dehydrogenation of alkyl halide will give ethene. Okay, dehydro water, hydrogen, and halogenation mean bromine. When bromine and hydrogen is removed from the adjacent carbon atom in alkyl halide, what will happen? It will be converted into ethene. Okay, so option B is correct here. Which of the following reaction will yield 2,2-dibromopropane? Now look at here, option A. You have to strictly follow the Markovnikov rule. Okay, so when you react this one with this, okay, so it will give these 2 hydrogen will be attached to that side where the hydrogen atom is greater. Okay, and bromine will be attached to that side where hydrogen is less. Okay, so it will be attached to this one. So this one, the reaction of these 2 will give 2,2-dibromopropane. Look at here, dipropane. Option A is correct here. Okay, the compound which reacts with HBr according to Markovnikov rule. Look at the A option. This one is symmetric. Option B is also symmetric. Option C is also symmetric. So there is no such restriction for symmetric molecule to follow the Markovnikov rule. Okay, only asymmetric molecule will follow the Markovnikov rule. So here option D is asymmetric. So this one will react with HBr according to Markovnikov rule. Which one of the following hydrocarbon will give product through substitution reaction? Now you have to find which one is alkane. Okay, C2H4 is alkene. Okay, and C3H6 is also alkene. C4H8 is also alkene. So C2H6 is alkane. Okay, like we know that the formula of alkane is CnH2n plus 2. So 2 2s are 4 and plus 6. So this one option is correct. Okay, alkane will undergo the substitution reaction. 65. Which of the following is the strongest acid? Look at the option A, B, C and D. So keep this in your mind that the acidity of alkyne is greater. Okay, and the first one is alkyne, so option A is correct. Look, this one is benzene and this one is alkene and this one is alkane. So the acidity is greater for alkyne because it has sp hybridization, and in case of sp hybridization the electronegativity is greater. What happen, and the orbitals are closer to the nucleus. Okay, so in this case the electronegativity of the carbon is greater, and this carbon attract the electron towards itself. Okay, so the hydrogen can be easily detached from this one, so this one has the greater acidity. The metallic ethanides are formed by the reaction of dash with ammonical silver nitrate or ammonical cuprous chloride. So we know that acetylide can only be formed by the acetylene or terminal alkyne. So the terminal alkyne in this case is acetylene. Option B is correct here. Propine and propene can be distinguished by, so propine is the terminal alkyne. Okay, and we know that terminal alkyne can react with AgNO3 silver nitrate and in ammonia. So we can distinguish by reacting it with silver nitrate with ammonia. So option D is correct here. Okay, ammonical silver nitrate react with ethyne, ethylene. So this one is terminal alkyne. Okay, so this ammonical silver nitrate will be react to terminal alkyne. This angle in HCH angle in ethene is, so we know that ethene is sp2 hybridized and it has 120-degree angle. Option A is correct. Which statement is true regarding reactivity? Double bond is stronger than single bond, hence alkene are less reactive than alkane. So this statement is totally wrong. Okay, because double bond is weaker than single bond, and we know that alkenes are more reactive than alkane. Look at the B. Alkenes do not undergo addition reaction. This one is also incorrect statement. Okay, alkenes undergo the addition reaction. Alkenes decolorizes bromine solution and bears reagent, but alkyne do not. This one is also incorrect. Okay, because the alkyne can also decolorizes the bromine water and bears reagent. Look at the D. Towards the electrophilic addition reaction, alkenes are more reactive than alkyne. Okay, option D is correct here because alkene has less charge density. Okay, and that's why the charge can be easily available, electrons can be easily available for the electrophile, while in alkyne the volume is greater in pi bond. Okay, so in that case the electron are not available to the electrophile. So option D is correct here. The carbon-carbon bond length in benzene is, now we know that in benzene the carbon-carbon bond length means the double bond in the carbon-carbon and the single bond in carbon-carbon are same. Okay, so that's why we can say that they are in between the alkyne. Look, this one is alkene. The double bond, they are in between alkene and alkane. Okay, sorry, this one is alkene and this one is alkane. Like the double bond is longer than the double bond in normal double bond. Okay, the double bond in benzene is longer than the double bond in alkene. Okay, and the single bond in benzene is shorter than the single bond in alkane. That's why they are in between the alkane and alkene. Okay, and the length is 1.40 Armstrong. Okay, the double bond and the single bond has same length in benzene. The compound formed as a result of oxidation of methyl benzene toluene by KMnO4 is benzoic acid. Okay, this benzoic acid formed by the oxidation of toluene. The electrophile involved in the sulfonation of benzene is, now the actual electrophile is SO3, okay? Actual electrophile in benzene, this electrophile is called polar electrophile. Look, this SO3, we know that the final product is sulfonic acid. This hydrogen is attached later in the reaction, okay? But the original electrophile is SO3. Let me show you the mechanism. Look at here. This is the mechanism for sulfonation of benzene, okay? First of all, the 2 moles of sulfur hydrogen sulfuric acid broken into H3O, okay, positive, and HSO4 and SO3. Look, this is SO3 is the electrophile. Then what happened in the next step, this SO3, one bond in SO3 broken down and it become S positive and O negative. So this S positive combined with here benzene, okay? So it become SO3 negative, hydrogen and positive charge is here. Now look at here. This is the sigma complex. It means that they're delocalizing. These 2 bonds are constantly delocalizing, okay? So this structure is called sigma complex, okay? Now look at here. When this bond is broken down, this HSO4 attack on this hydrogen and it become the double bond is the double bond is formed here, okay, and it become SO3 negative and benzene ring. So and here sulfuric acid form again. Now look at here, this H3O positive give hydrogen to this negative charge, okay, so it become SO3H and with benzene ring plus water, so it become the sulfonic acid, okay. Now look at here, what is the original electrophile? It is SO3. So we in MCQs the correct answer is SO3, option B, okay. 74. Which of the following reagent would be the best reactant for the following synthesis? Now look at the reactant. This is the benzene, and on product side this is C double bond OCH3, which is acetophenone, okay, and this reaction is known as Feudal Carboxylation, okay. And we know that in Feudal Carboxylation what we use acetyl chloride with AlCl3, aluminum chloride, okay. So the best reagent is the acetyl chloride and AlCl3. Look at the option. Look at here, option C is the correct, okay, acetyl chloride plus AlCl3. In electrophilic aromatic substitution reaction, the nitro group is meta-directing because, now what is meta-directing? Meta-directing are the groups that decrease the electron density at the ortho-para position, okay, and in turn they are called meta-directing. So look at the option C, that nitro group decrease the electron density at the ortho-para position, and thus the electron density is greater at that time in the meta position, okay. That's why they are called meta-directing, okay. Its action is like only decreasing the electron density, okay, at ortho-para position, and in turn at meta position the electronic density is the same, but still the electrophile would attack at meta position because it has a greater density as compared to ortho and para. 76. The presence of a nitro group in benzene ring. So we know that nitro group are the deactivator, okay, so it deactivates the ring toward the electrophilic substitution reaction. Option D is the correct, okay. We know that meta-directing group are the deactivators, okay, so option D is the correct. The compound which has all CC carbon-carbon bonds of equal length, okay, so we know that in benzene the double bond and the single bond of carbon-carbon, they are same in length, which is 1.40 Armstrong, okay, so option A is correct here, okay, because the pi bond in benzene is delocalized, that's why the length of both double bond and the single bond is same, okay. All of the following are electron donating species, but one of these is deactivating, indicating the species. Now look at here, these all are the electron donating species, but look at here, chlorine deactivates the ring of benzene. This is because in case of chlorine is the most electronegative atom, okay, like halogen are the deactivator of benzene ring, so that's why they are the most electronegative in nature. So in these 4 options chlorine is the most electronegative, okay, that's why instead of activating the group they deactivates the benzene ring. Okay, so chlorine are the deactivator. There are two properties of chlorine, like it donates the electron, okay, it has the lone pair, and also they are the most electronegative in nature. So in this case the electronegativity of chlorine dominates. Okay, so that's why we says that they are deactivating. Which of the following statement is not correct? Okay, not. A compound with greater stability has lower heat of hydrogenation. This one is the correct. Okay, stability is inversely proportional to heat of hydrogenation. That's why the unstable compound will release high heat, okay, heat of hydrogenation, and then it will get stable, while the stable compound will release low heat of hydrogenation. Okay, now look at the B option. A compound with greater stability has low heat of combustion. This one is also correct. Okay, because the greater stability of compound, thus they release the lower heat of combustion. Benzene, being aromatic, react readily with bromine water to form additional product. Now benzene is an aromatic, that's why it will not react readily, okay, with bromine water. Okay, in order to form an additional product, it will undergo the severe conditions. Okay, so that's why here the readily is present, so this statement is incorrect. Okay, the statement of the MCQ was that which one is not correct, so this one is not correct. Look at the D. The actual electrophile in benzene sulfonation is SO3, so this one is the correct. Okay, the actual electrophile in benzene sulfonation is SO3. Which of the following statement rules out the accuracy of Kekulé structure for benzene? Option A is all carbon-carbon atom is in benzene are of equal length. First of all, let me show you what is Kekulé structure. Look at here, these two are the Kekulé structures, okay, and these three are the Dewar structure. So let me show you what is the MCQ. Which of the following statement rule out the accuracy of Kekulé structure for benzene? So option A is all the carbon-carbon bond in benzene are of equal length, so this one is correct. Okay, benzene has lower heat of hydrogenation. This one is also correct, because benzene is the stable structure, and the stable structure release low heat of hydrogenation. See, benzene on bromination give only 1,2-dibromobenzene with no other isomer. So it means that when bromine is reacted with benzene, so it will give only one product rather than 2 or 3. So option C is also correct. So it means that all of the above are correct statement. The resonance stabilization energy for benzene is, now look at here, we know that the resonance stabilization energy for benzene is 152 kilojoule per mole. But if you want to convert it into calories, then look at here, 1 kilocalories has 4.2 kilojoule. Okay, so 152 kilojoule has x kilocalories. Okay, now look at here, x is equal to 1 divided by 4.2 and multiply by 152. Now look at here, when we multiply, look, this point will come here and put 0 here. Okay, so it will be 10 divided by 42. Now look at here, just divide this 152 by 42, so it will give 3.6. okay, now multiply this 3.6 with 10, so you will get 36 kilojoule per mole energy. Okay, so look at here, option B is correct. Okay, the structure for benzene is, now we know that benzene is hexagonal, okay, and it has sp2 hybridization. So because of this sp2 hybridization, benzene got the structure of hexagonal planar. Option B is correct. The actual electrophile in the nitration of benzene is NO2 positive. Option B is correct. Okay, now look at here, this one is the mechanism for the nitration of benzene. Okay, take this HNO3, okay, plus H2SO4. Now this H2SO4 will, this hydrogen will come and combine with this oxygen. Okay, so it will become HSO4 negative and oxygen. Look, this is coordinate covalent bond. Okay, and oxygen got the positive charge. Now look at in next step, this electron will be attracted by the oxygen. Okay, so it will become water plus NO2 positive, so the actual electrophile is NO2 positive. Okay, so in next step, this NO2 positive will attack on the benzene ring, and what will happen, this one bond will be broken, and here positive charge will come and negative charge will come here. Okay, so NO2 will be attached here, so it will become NO2 and H bond. Okay, So in the next step, what happened, this hydrogen is this bond is broken down and it become again the double bond, and this HSO4, this will get this hydrogen. Okay, so it will become H2SO4 and nitrobenzene. Okay, so this is the mechanism for the nitration of benzene. 84. Actually benzene has no double bond. Okay, we have studied in resonance that the actual structure of benzene is like this. Okay, the pi electron of benzene make it nucleophilic structure. Okay, because they have negative charges. Okay, not charges, sorry, negative electron, and you know that electron are nucleophilic in nature. Okay, so the pi electron make it nucleophilic center. The unexpected lower heat of hydrogenation of benzene is due to the delocalization of electron. Option A is correct. Okay, look at here, stability is directly proportional to delocalization of electron. Okay, and stability is inversely proportional to the heat of hydrogenation, so option A is correct here. Feudal Carboxylation is not successful in one of the following substrate. Indicate the substrate. Now look at here, benzene is given, phenol is given, and here the nitrobenzene is given. Okay, so let me tell you that when hydroxyl group is attached to the benzene, it increases its reactivity. Okay, when the nitro group is present with the benzene, so what happens, it decreases its reactivity, so option C is correct here. Okay, like it has deactivated the ring.